today's lesson we're talking about dilations, and just a reminder there will not be any notes for lesson 19.2. So a quick review of transformations, which is from Math 1. We have translation, reflection, and rotation. So these three are considered as rigid transformations because they do not change the shape or its size. So when it's translation, you either slide or glide, that's what we call it, and what that means is you're either moving to the left or to the right, or up or down. Reflection is considered as a mirror image, such as over the y-axis, or what I like to call it, if it's over the x-axis, it's like you're looking down at a body of water and you see your reflection under. Rotation is turning, and for rotation you will need measurement in degrees, like 45 degrees or 90 degrees, to measure the angle of rotation. Moving right along, the pre-image is your original figure, and you always label it with capital letters, versus your image, which is your transformed figure, and the way you would label it is with a capital letter, the same letter as the original, but with a little tick mark or apostrophe, and you would read it as A prime. If you have two of these tick marks, then you would read it as A double prime. Alright? For this lesson, we are talking about dilation, which is not a rigid transformation. So dilation is basically when you're making a figure that's going to be larger or smaller in size, but it does not change the shape. Think about when you're taking a picture, zooming in versus zooming out. That's what dilation is all about. And it does require a scale factor, which we like to call the letter K, that's our scale factor, to determine how large or small an object will be transformed to. And a center of dilation is a fixed point where all the points are enlarged or reduced. And again, just a reminder, just because it's called center of dilation, it's not always or necessary for the point to be in the center of the pre-image. It can be anywhere on the plane. So you use center of dilation a lot in art. It's not sure the exact name to call it, but it's like a point of your perspective or perception. So that's the center of dilation. So when your center of dilation is at the origin, and for example, if we're trying to reduce, so this is an abbreviation of reduction, if your scale factor is half, and whatever your ordered pair is, what you do is just take half of each ordered pair. But if you're trying to enlarge an image, and you have a scale factor of 5, you just multiply it by that number. So scale factor, when it's a reduction, that number is between 0 and 1. If it's an enlargement, it's greater than 1. So once again, when the center of dilation is not at the origin, the location of the center of dilation will be given, such as these examples. So here's an example. If they give you a pre-image, as in an ordered pair, and they indicate what the scale factor is, they also will tell you the location of your center of dilation. So here you have a formula that you will need to use to find that new coordinate. Okay? And it is color-coded. So here's an example. If you have a triangle, so this is A, B, and C, and each of the vertices are at these locations. For A, it's -2 and 4, B is at 1 and 2, C is at 1 and 0. And that scale factor is 3. That means each one of these needs to be multiplied by 3. However, there's a center of dilation somewhere. So we got to plug it in and calculate to find out the new coordinate. So after we plug in all these information, you do your basic calculation, and it comes out to be -4 and 2 for your A prime. So A prime is -4 and 2, and if you look at the pre-image, A is -2 and 4. It doesn't mean that your digits will always swap, okay? And also, it's not as simple as just multiplying each of the coordinates by 3, like mentioned earlier. that only happens when your center of your dilation is at the origin. But since it's not, it's at -1 and 5, we have to do all these calculations. And you would do the same thing for B and the same thing for C.